got our history states working. Almost. There are a couple small inconsistencies that we need to deal with before we move on to the next episode. Now, I didn't have time to do a ton of testing on this like I normally like to do, but we're going to go ahead and take a look at some of the issues that most people have had with the history states. Let's start with the first one, and that is making sure that our characters face left and face right throughout the history states. Now, I did cover this in the previous episode, but it could have easily been overlooked since it wasn't highlighted so well. But let's make sure that when you come down and capture the character data, that for every character, make sure that you cache the is facing left value to equal the is facing left value of the character. That way we log whether they're facing left or right. And when we go to apply it, make sure that we check if the character data that was recorded is facing left, that we cause the character to face left. Otherwise, we cause the character to face right. If we don't do that, you'll find your characters always face to the right of the screen, no matter what. But if you make sure to include that check, then everything will work fine. The next issue let's look at is if you're using the typewriter style for your text architect, which I've been using Fade, then you may notice that if you go back through history states, then the prompt will appear in an incorrect position for the given text on the screen, or the text just won't show up and fill out all the way. This is because the maximum visible characters is not set to the right value when you're moving back and forth between history states. As the text architect builds text, it's constantly increasing that value until it reaches the end. So if you stop at a short line and then go back to a different history state that has a larger line, you won't get the full text. So we need to make sure that that max visible characters is updated for every history state that we try to recall. To replicate this, I'm going to come into the initialization of my dialog system and make sure when I create the architect, I'm creating it as a typewriter instead of a fade type. And you can see this is the case when I've gone back to a short line and then try to head back to a longer line, I get a partially completed text line, and that's not correct. So to handle this, we want to come into our dialog data where we apply the previous state to the screen. And instead of assigning the text directly to the dialog text, which doesn't take visible characters into account, what we can do is instead call a function on our text architect that will force it to update everything as it should. So we'll reference the dialog system and grab our conversation manager and grab the architect from that and say set text, and set the text to the dialog data, whatever I called it. I think it was data. Yep, data.current dialog. And we'll go ahead and remove the direct assignment for the dialog text beneath it. So we're going to be assigning the text directly to the text architect. Again, that's because we need to account for max visible characters on the typewriter style. So if we go to set text, what that's doing is it's going ahead and applying the text to the actual Text Mesh Pro object, and then it's stopping any coroutines, and it's calling force complete. So if we look at the force complete function, which is on the typewriter section of our text architect, if you were operating on the script where all of these are together, just look for the force complete function. Or if you downloaded the updated text architect from the Discord, then it'll be inside of the TA Builder typewriter script. Either way, you're looking for force complete, and you want to make sure that the max visible characters are assigned to the actual character count for the Text Mesh Pro object. Now, interestingly enough, that doesn't actually do anything for us. Actually, it does, but we get some incomplete text. Now, take a look at this. We go back to the last line, and we only get partially generated text. If we go back to the line beforehand, let's go back to the previous line here. We only get a partially completed line, but if we were to go back a little further and then go right back to that line where we were only getting partially completed text, we now have a little bit more. So we can see that it's not getting the right character count. And the reason for that is, of course, before we go assign those max visible characters, we just want to say architect.tmpro.forceMeshUpdate, so we get the latest state of the text. And with that, we can now go through all of our states, and everything works correctly. The next issue that someone noticed was that If you don't go through any history states, if we pull up our logs, we have absolutely nothing in there. So if we try to go back, then we actually get an out of range error. So we're not supposed to actually move back through history states. We have no history states to move back through. So we need to head into our navigation script and check that out. This is coming from our history navigation when we try to go back. So we are making sure that we can't go back if our progress is already 0 and we're viewing history. Meaning, if we're viewing history, we can't go any further back than the very beginning. But that doesn't take into account if we are not viewing history, so we just need to make sure that we also tack on a check to see if our history.count equals 0, or any of the following conditions. And now as I go ahead and relaunch, if I try to go back, I can't, but if I go to the next line, and then try to go back, I can because we have a valid history state generated. Now, the next thing is not so much an issue, but it is just a little addition that I would like to make. It will make things a little nicer, particularly for our history logs. So if we go ahead and look at a history log that has a whole bunch of stuff in here, I'll just scale that up just a little bit, you can see that we can drag this log all over the place. Anyone who's worked with scroll views knows how to fix that, but for those who don't, let's go ahead and take a look at this. So we've got our scroll view here, and we want to go to our script. And when we have movement type, we could go ahead and set elastic, unrestricted, or clamped, and then that would just change whether we have this bounciness to it, such as that recovery there. So we could change it from elastic to clamped, and then we can't bounce it anymore. We can't go outside of the history logs. So that's nice there. And it also keeps us from being able to go out on the sides. So we are now restricted to this whole content area, and that's much nicer for our logs. Now the next thing I noticed with the history state is we never saved animations. So with our little sprite character here, I've gone ahead and said that now she is cold and wet, so she starts shivering. Now if I go back to the previous state, you'll notice that that actually doesn't stop. So we need to cache the animations. Again, this is applying to the root animations on the root character container, not any sort of sub-animations for bones or the specific things you would do for your character types. This is for all characters in general, so we're going to do it this way. Now we have a data JSON, and data JSON is for each of the character types, whatever sort of data they need in particular, but as a generalization, we're going to have another data JSON simply for our animations, because we could have any number of animations and we don't want to store each of them individually. It just wouldn't be neat and it wouldn't look good. So we're going to do it simply and easily using JSON. So we'll make another public string, and this will be the animation JSON. This will have all of the animation states, and we'll be able to cache them and recall them for each of our characters. So we need some data to put in our animation JSON. It'd be great if we could serialize a dictionary and save that, but we can't do that. So unfortunately, what we need to do is make another data class. Just like we did for our sprite data, we're going to make a new class for our animation data. So system.serializable, we will call this a public class for animation data. And the animation data is going to have a list of all sorts of different animation states. So we'll have yet another class in here, system.serializable, public class animation parameter. The parameter will have several values. We're going to want the parameter name, so we'll have a public string for the name of this parameter. So that'll be the name, a public string for the type of this parameter, which will be a type, and we'll have a public string for the value. So a public string value. And our animation data is just going to have a list of all these parameter types. So we will make ourselves a public list of the animation parameter for parameters. Okay, great. So now when we actually go to capture this state, we need to generate all of the animation data. So we'll go ahead and make a new function for this. It'll be a private static string, so we can return the JSON string format, and we'll call it getAnimationData. What we're going to need is the animator of our character. But I'll go ahead and pass this in for the character so I know exactly what this function's for. So I'll pass in the character called character. And so our animator is where we're going to get all of these parameters from. So animator equals character.animator. And now let's go ahead and grab all the parameters. So let's get ourselves some animation data in a cache here. Animation data equals new animation data, and we're ready to rock and roll. So let's go through every parameter in this animator. So for each var param in animator dot parameters, we're going to go through and generate a new animation data object for this. So we'll make ourselves, what did we call this? Animation parameter. So we'll make a new animation parameter called p data as a new animation parameter. And let's figure out what this type of animation is we're working with. We're really only supporting booleans right now, but just for future proofing, let's go ahead and add floats and integers as well. So we can go ahead and do a switch statement and evaluate this off of the parameter from our animator and check out the type. So depending on what type this is, we're going to save the value for it. Let's start with a boolean. So let's say the case is for a boolean. This is our first type. If this is our parameter, then let's go ahead and say that pdata.type equals a boolean. So that way when we go to apply this, we know what type it was and we can figure out the right value. And then let's say pdata.value is going to equal the animator.getBoolean, and we're going to get it by the param.name and convert that to a string. So we get the type and we get the value, and when we create this, let's just go ahead and also specify the name of this thing. So name is going to equal the param.name, so that way we have all three values ready for us. Okay, so if that's a boolean, we get it as a boolean. Otherwise, we can get it as potentially a float or an integer, which I don't have set up in the character states, but maybe we'll add that later on, or maybe you will. I don't think I will, but I'm going to go ahead and add this in anyway. So get float or get integer rather. So we'll get any of those types, and then we just need to return this data as a JSON string after we've added it to our data, that is. So let's go ahead and say that data.parameters.add the data that we just generated for this animation state. And then we will go ahead and return JSON utility.toJSON for our data. And that'll get us all of our animation data. So when we capture the character, let's go ahead and make sure that we capture that as well. So entry.animationJSON equals get animation data from our character. Now, how about applying it? When we go to apply it, instead of getting the animation data, let's apply the animation data. So private static void apply animation data, and we're going to take in the character that we're applying this to, as well as the animation data. So animation data, which we will call data. So let's go ahead and go through each of the values in our parameter data. So let's start first by just going through a for each loop. So for each var param in data.parameters, let's check out what type it is. So switch param.type. And let's evaluate. So the type is saved as a string, so we'll look for the first one as a boolean. And if it is a boolean, then we'll go ahead and say character.animator. Maybe I'll just cache the animator up here. So animator equals character.animator. And so I'll eliminate character and just say animator.setBool And this will be setting the data.param, or the param.name, setting the param.name, and we're going to get our value as a boolean. So we can say bool.parse and get our param.value. Wow. Visual Studio throwing me all kinds of things. All right, so we apply that, and then we're good. Now, if we're doing a float or an integer, that'll be a little different, so we'll change that to float. We'll change this to integer, and we'll change setBool to setFloat. And instead of bool.parse, it'll be float.parse. Instead of setBool, setInteger, and then int.parse. And that should reapply all the animation states to the character. So when we go to apply the character data, then right after we set the character is visible, let's go ahead and get our animation data. So animation data equals character data, the parameter here, character data dot animation JSON, but we need to convert that from JSON. So JSON utility dot from JSON, and let's specify the animation data type, and just encapsulate that as the parameter. So we'll go ahead and grab our animation data, and then we'll go ahead and say apply animation data to our character, passing in the data that we just extracted. Now, if we go and play this in the scene, we can see we have our animation JSON string, and it does indeed get all of our values, but it's grabbing our triggers, which we don't need to save. As you can see, the type is referenced as nothing, and there's no value for a trigger. We actually don't need to set them because they are one-time events. So let's make sure that we just exclude the triggers. So when we get the animation data, before we go and create a new parameter data object, let's go ahead and check the type first. So if param.type equals, and we're going to be looking for the type of the trigger. If it is a trigger, continue, because we don't want to add that to our save values, because there's no need to save a trigger. And now if we look at our parameter values, we only have the boolean for shiver, and whatever other values you might have had. But we can see that hop, which was a trigger, and refresh, which was a trigger, are no longer present. So we should be able to go through, and now Raylene has started shivering, so if I go back, she stops. If I go back forward, well, that didn't happen. So the question then is, why did it not work when I went back to the state where the boolean was true? It did stop the state, but when I went right back to it where it should have been true, it didn't set it back to true. And that's just because it's been so long that I even forgot how this animation worked. So we pop the shiver, but you can see that doesn't do anything until we hit refresh. So refresh actually needs to be called whenever we reset these animation states. So after we apply the animator, then we want to go ahead and refresh the character animation as well, so it will take these new values. So we can do this down in the apply animation data, and once we're finished, we'll just go ahead and say animator.setTrigger, and we can call the constant that's already been defined for the refresh on the character class by saying character.refresh, animation refresh trigger. So we will force the animations to refresh. Again, I have to do this because I defined refresh the trigger as a requirement for the transitions on the animators of this animator controller. Okay, and there we go. So we can have our state with the animation, and we go to the other ones, and it only keeps the animation on the state where it was active. Now, this is a very complex system, and even with released packages that you purchase on the asset store, the developers of those will release little patches and updates as they find issues. So I may not have addressed everything in the history state system. I think we have a very good standing where we are, and we have addressed maybe everything, but if you happen to find something that does not work or you have questions, then please let it be known in the comments or the Discord channel, preferably Discord because I check that more often, but also the comments help with the YouTube algorithm. So just let us know, and then we'll go ahead and either address it in a video or within the chat. But for right now, that goes ahead and takes care of our history system, and we have a very nice working state for our visual novel. So I will end this episode off here, and I hope everyone has a wonderful day. If this helped you, leave a like and a comment down below, and I'll see you guys in the next video.